Welcome to this video, where we will explore the process of shutting down refrigeration systems due to low pressure, known as pump down. Essentially, the shutdown due to low pressure is a crucial procedure in refrigeration or air conditioning equipment. It involves collecting refrigerant from this part of the liquid line, passing through the evaporator, suction line, and storing it in the discharge, up to the condenser, with a special focus on the liquid receiver. The main objective of this strategy is to prevent the flooded start of the compressor and the liquid impacts caused by the excessive migration of refrigerant that remains trapped in the evaporator. Furthermore, this low-pressure shutdown strategy is recommended for equipment using hydrocarbon or flammable refrigerants. Its primary function is to reduce the presence of flammable refrigerant mass in the refrigerated space, especially in the suction line and evaporator. In this case, it is considered more as a safety measure. The essential components to implement the pump-down or low-pressure shutdown system are: A. Low-pressure switch, preferably dual. B. Liquid solenoid valve. C. Electronic refrigeration controller. The low-pressure shutdown procedure can be summarized in 10 steps. 1. When the equipment needs to shut down, for example, during defrosting, the controller closes the solenoid valve. 2. Upon closing the solenoid valve, the normal flow of refrigerant gas is interrupted, but the compressor remains on. 3. The running compressor suctions the remaining refrigerant in the evaporator and suction pipe. 4. As the compressor suctions, the pressure drops below normal as the suction begins to have less refrigerant. 5. When the pressure reaches an assigned value, the low-pressure switch detects this low pressure and disconnects the compressor. 6. Upon shutting down the compressor, the pressure in this zone is very low, reducing the amount of refrigerant. 7. For example, at the end of defrosting, the equipment must be turned on again. When the equipment starts, the controller opens the solenoid valve without turning on the compressor yet. 8. Upon opening the valve, some refrigerant reaches the evaporator and suction due to the pressure difference, with the compressor still off. 9. When the pressure in this zone increases to a certain point, the low-pressure switch detects a higher value, and at this moment, the switch connects the compressor. 10. Now, when the compressor starts, it begins working with the minimum amount of refrigerant, avoiding issues like excessive refrigerant startup and compressor stress. At this point, the working pressures start to normalize.